Hello and welcome back to Maths Tutorials. Today we're going to be talking about the mean value theorem and also Rolle's theorem, but basically the same thing you're going to see. But so a reminder, this series is calculus refreshers, just to kind of remind you of some fundamental things about calculus. This is not supposed to be an in-depth sort of lesson, mostly just like if you already kind of remember it, this will remind you a bit. So the mean value theorem is the one that says if you have a point A and a point B, and you have a smooth curve, right? Uh, sure, something like this. You have a smooth curve. If you draw a line from point A to point B, straight line, then if the curve is, um, I think what differentiable, um, and continuous, something like that, then there is a point where the slope of the tangent line is equal to the slope of the line between the 2 points. So if say this is A and this is B, and there's some point C about there where the slope of the tangent is parallel. All right, these two lines are parallel. So that's what the mean value theorem says. Now the Rolle's theorem is basically the mean value theorem, but for when A equals B. So if you have something like this, it's basically just saying if you have A equals B, okay, I can't write an A apparently. If you have A and then B and they are the same, right? They're on let's say like they're on the same y line, then that just is saying Rolle's theorem is saying that at some point you have a slope of 0, which can be important for some things, such as finding minimums or maximums. But you can see that Rolle's theorem is basically just a more precise version of the mean value theorem. It's basically a special case. So with that in mind, let's do this practice problem. Determine all the numbers C which satisfy the conclusion of Rolle's theorem for f of x equals x squared minus 2x minus 8 on the interval -1, 2, 3 inclusive. So first, let's just make sure that we can actually use Rolle's theorem. All right, so, well, one, we know that we can use it because this is obviously a polynomial, right? This is going to be a parabola of some sort. So we know that it's going to be smooth and differentiable. We don't have to worry about all that. But let's just make sure for Rolle's theorem, we need A and B to be the same. So in this case, -1 is A and 3 is B. So basically, f of A has to equal f of B. So let's verify that. So f of -1 looks like is -1 squared, so 1 minus -2 times, or -1 times 2, so plus 2 minus 8 equals -5, and then f of 3 equals, let's see, 9 minus 6 minus 8, which is 3 minus 8, equals -5. Okay, so we have verified that, which is good. So now we know we can use Rolle's theorem. So all the numbers C. So C refers to the x value where the derivative is 0. So if we're looking at this right here, this x value would be C. So this is what we're trying to find. So we know the slope is 0 somewhere, but we have to find where. So what we can do is we can find the derivative of f, right? We can find f prime, because what f prime tells us is the slope at every point. So what we can kind of do is take f prime, the slope at every point, and find out where that equals 0, where f prime equals 0, and the x value at that point will tell us what c is. So what is the derivative? If you recall from my other calculus refreshers, we can just use the power rule. Pretty straightforward. That would be 2x, right? Bring down the exponent and then subtract 1 from the exponent. Minus just 2, and then the 8 doesn't matter. So now we have this. And so we want f prime, oh, let me write this, f prime of c equals 0. So what we want to do is say 2x, or instead of x, it's going to be c. 2c minus 2 equals 0. So it looks like 2c equals 2, and then that would mean that divide by 2, right? C equals 1. All right, so let's just make sure that this works. If we plug in 1, right, 2 times 1, right, is 2 minus 2. So we're good there. And also let's make sure 1 is in fact in our interval from -1 to 3. So it looks like c equals 1. So of course that this all hinged on the fact that this is, continuous and differentiable and a equal b. So let's do another problem since that one was pretty short. Um, all right, let's do one that's not Rolle's theorem because that's Rolle's theorem is honestly like simpler than the mean value theorem. So let's do this one. Sorry, just copy pasting the problem. All right, here we go. Let's do this problem right here. So h of z equals all this. And okay, so for one, they changed the variables. It's now h of z and z, but it really doesn't matter. It's saying the same thing. So I don't know what this polynomial looks like. I do know it's a polynomial, obviously, of degree 3. It's going to look something, like this. And we're saying from 2 to 5. Oh, by the way, the question is, um, yeah, let me just get this here. All right, sure. Determine all the numbers C which satisfy the conclusion of the mean value theorem for the given interval, function and interval. Okay, so the mean value theorem again. So let's say this is 2, let's say this is 5, and remember these are the x values. Whatever this line is, we're trying to find the point where the slope tangent at that point is the same as this line, right? It's parallel. So it looks like, this sketch isn't accurate, I don't think, to the actual function, but if it was, it'd be about right there. And that's what we're trying to find. So first, what we need to do is actually find the slope from x equals 2 to x equals 5. So what we can do is find what these points are, and then of course do change in y over change in x, which is rise over run. So we need h of 2 and h of 5, right? We need that first. So h of 2, let's see, 4 times 2 to the third minus 8 times 2 squared plus 7 times 2 minus 2 equals, all right, let's see. So that would be what? 8 times 4, 32, minus 4 times 8, so 32, plus 14 minus 2. So that looks like that's going to be 12, right? Because these cancel out, basically. We're looking at that. And then 5, that would be 4. I can just copy from the one above. That minus 8, 5 squared, plus 7 times 5 minus 2. So that would be what? 4 times 125 is, I'm not looking this up right now. Okay, 500. 500 minus 8 times 25. Again, I'm not looking this up right now, but if I was, I would see that it's 200. Plus 35 minus 2 is what? 300 plus 33. Oh, wow. 333? Is that really right? That's crazy. I mean, I guess like once you start getting to like degree 3, the numbers grow pretty quickly, I suppose. But anyways, all right. So we have let's say 2 comma 12, and then we have 5 comma, oh, that's not how you do an ordered pair, 5 comma 3 3 3. Now that sounds really stupid, so let me actually like double check that that's what I'm dealing with here, because that sounds incorrect. Okay, well, that is right. All right, so we're dealing with something like this. So realize that for the mean value theorem, it doesn't matter what the curve is, like what it looks like, as long as it's, you know could look like that, could, do something like that. As long as it's continuous and differentiable. I think it has to be with those things. Um, yeah, it does have to be with those things. As long as it's continuous and differentiable, we can use this. It does not matter what it looks like. So, we would do rise over run, right? Because we're trying to get the slope of this straight line. So the rise, it goes from 12 to 333, which would be 333 minus 12. So it would be 3, 2, 1, I think, over the run, which is 3, which equals what? 107, I guess. So now we want to find where the slope equals 107. Or we already know where it's equal 107. Well, the slope is 107. So we want to find the point where the derivative is 107. So the derivative, right, h prime of z is, let's see, 12z squared minus 16z plus 7. Okay, so 12z squared minus 16z plus 7 equals 0. And I think I'm just going to do the quadratic formula. So negative b plus or minus root b squared uh, minus 4ac all over 2a. Okay, so now we use a calculator because I'm too lazy to do all this stuff. So let's see. 256 minus 4 times 7 times 12 is negative 80. Boy, that sure doesn't sound. Oh, I bet. Huh. Interesting. Let me see here. What am I doing wrong? Okay, 107. Oh, no, this isn't equal to 0. Right, I was doing like Rolle's theorem again. It's not equal to 0. It's equal to 107. Equals 107. So really, it's this. Subtract 107 on both sides, and that would be minus 100 equals 0. There we go. And now you could probably do like some dividing stuff, right? You could probably divide by 4, right? So 3z squared minus 4z minus 25 equals 0. I don't know if that makes it any easier, but let's see. Negative b plus or minus root b squared minus 4 a times c all over 2a. Okay, so now what's this? 16 plus 4 times 25 times 3. 316, maybe. Well, let's see. So that would be what? 4 plus root 316 over 6. So that would be about 3.629. And that is in fact the answer. So so C equals 3.629. All right, so we got it. So that should be it. I think this is pretty simple. I was even able to do 2 practice problems in this one, the second one being a little bit more complicated. And I still, it's still a relatively short video, so I don't think this is too hard of a concept. Again, mean value theorem, it's pretty important, I'd say. The main thing that comes with applying it to like word problems, like the one where it's like, oh, a dude went up a hill and then another guy went down the hill. When they passed each other at some point, whatever. Prove it. I don't know, something like that. I've seen problems like that, and it kind of just shows this is a very versatile theorem. And of course, Rolle's theorem is basically the same thing. I don't even know why it's separate, to be honest. But anyways, thanks for watching. Next video, let's see. Let's pick a topic, as we always do, out of the calculus textbooks that I definitely didn't steal from the school. Um, let's see. Increasing and decreasing functions, first derivative. Oh, okay. We can do next time on Naruto Shippuden, we will do second derivative stuff, um, including concavity. So we'll go over all that stuff. I think I kind of already covered, I mean, obviously the process of getting a second derivative I already covered in the first derivative video, but there are some things that the second derivative tells you about a function that I think should probably warrant its own video. All right, so that'll be next time. But for now, thank you for watching and see you next week. Goodbye.